Oops. So I had a friend in physics who said, oh, this is not a real proof, this is a show me proof. These kind of proofs are show me. You're supposed to prove something is check by check satisfies the definition. So in this one, it's the center that I defined online the other day where I was going 90 miles an hour, and you did the in-class assignment off of these centers too. I'm going to walk you through the proof. It's a checkbox theorem. That's why I always have those little checkboxes next to it, because I'm thinking ahead that maybe someday somebody will ask me to prove that it's one of these things. So I just go and check each one of them. So we're going to use the subgroup test theorem. I think I did this very fast online. I'll do it very slow here now. First I have to show closure. Closure is one of the big things for subgroups. If you have a subset, for example, I could say, let me take one and two from the integers. That's a subset of the integers, but it's not a subgroup because I take 1 plus 2, it's 3, and I'm out. So you have to be self-contained in the set. That's why the evens are so cool, because if I add any even, I get an even back again. The closure is actually a very important property. So what I have to show is if I have A and B inside the subgroups, the supposed subgroups, alleged, it's not been proven yet, then we know what that means. I have to show that A star B ended up being in the subgroup. And on these kind of proofs, I call them bookkeeping proofs, because it's not really about intelligence or anything. It's about keeping straight everything. This is where Ken Kalmanson, Dr. Mukherjee, they're really good at bookkeeping and keeping this straight, because they're very neat when they go through things. That's why I get jealous when I say, I wish I was that neat. Then I wouldn't be in all the trouble I am in. Again, I told you this before. Notice I use different letters. These are all traps that, if you're not familiar with writing proofs, or you haven't had experience writing proofs, these are traps that you fall in, where you're not really writing things out carefully, and you might be reusing a letter that you shouldn't be. So I used a different letter for the X and the Y.
I know that you can run into trouble using the same letter. It doesn't turn out to be trouble in this particular one, right? Because I don't think you ever used the Y.
So, yeah, I don't think it turns out to be one, but what will happen is if they use an X here as a dummy variable and they use an X here, suddenly somewhere in the proof X means something, and it means two different things actually, right? So that's the problem. Like in general, I would suggest, if you're a beginner at writing proofs,
I'm with you on in general, but the Y never even made it to this proof.
Right.
Okay.
Right. Another common mistake I see is A and B. You let A and B be in the group, in the supposed subgroup. I haven't proved it yet. And then they say this means A star B is B star A. That happens quite a bit. Well, you've already designated A and B are your arbitrary elements that you're picking out, and you're going to show A star B belongs to this alleged subgroup. If you use them now to write out your no, you're reusing them, and you're going to get all tangled up. So that's another trap I see. It's not that it's incorrect. It's just that it's just setting it up that you might end up in a lot of trouble.
Shouldn't X and Y belong to G and not C of G?
Yes, you're right. Yes. If you see an error like that and you see it on the video, just put it on under the comments. That's the best way to handle them. So what I need to show is that A star B belongs to this alleged subgroup. So I have my no here. So what do I need to show? I need to show that A star B star C, and this should be of G. C should be in G, right? That it commutes, actually it commutes with any element in the center. So these are all the commutative elements. So I need to show that it rotates around. So I did this very quickly the other day. I have to show that, notice that I wrote this out very carefully here, what I'm supposed to show. There's a lot of letters. So it's bookkeeping, right? I need to show that A star B commutes with an arbitrary element. So this, I explicitly wrote it out. So I started writing out the pieces, A star B star C, Well, I can rotate the parentheses. So this parentheses can move over here by associativity of the big group. And that's true because, and then I can rotate the B and the C because B belongs to that center. And so I get A star, C star B. Now I've rotated those around. And again, that's equal to A star. I can, by associativity, move around these two pieces right here. These two pieces move. And now this piece here turns around by property of the group, by the property of the alleged subgroup, right? That I can rotate the C and the A around. And now, in the last step, I'm able to move the C aside, again by associativity. And it is bookkeeping because I'm just documenting. It's almost like I am writing a brief. You know, I'm like documenting everything. So therefore, it's a closed set. I don't go out. And this idea of doing this, I've seen it further on in Fraley. They have other problems like that have more hair to them. Like there's more stuff to bookkeep and watch out for. So next, I have to show the identities in there. Well, that's easy. Identity commutes with everything, so the identity's in there. And finally, if A is in there, I need to show that the inverse is in there. This means I need to show A inverse commutes with any arbitrary C. So I pull my no, and then I hit both sides on the left by A inverse. And I can do that by the cancellation property. And then I can rotate those two things around by associativity. And the A inverse A kills by the definition of inverse. And by definition of E, the E goes away and I'm just left with X, because that's what E does to things. It leaves things unchanged. And last step, I'm going to multiply both sides by A inverse on the right. And that's going to knock out the A inverse and A. So I get X times A inverse is A inverse times X by all those previous properties. I'm not going to write them again. They're all upstairs. So I copied what I had on the previous slide. So that means that since X was arbitrary, A inverse commutes with all elements. So A inverse is also in the alleged subgroup. Now it's not alleged anymore by the subgroup test theorem. It is a subgroup. So this was a bookkeeping problem. The one we did, number 34, that wasn't a bookkeeping problem. That was a thinking problem. I had to think about it. Number 29 was totally a thinking problem. I had to think about, why does this work? That was interesting. So Saxon, that was the name of the physicist. Saxon was right. This is a show me proof, it's not a real proof. Okay, any questions on this?